Finding a good research topic and completing your degree or master's degree dissertation or even your doctoral PhD thesis may be somewhat of a daunting task. From looking for the right research question or topic to backing up your claims with concrete facts and reviewing a ton of literature or articles, this may be an ongoing process. Now, for some universities, especially at the degree level, you might be required to review about 40 journal articles. That's just for the core literature review table. Yeah, doesn't account for other aspects of the other citations in your paper. So maybe you might make a maximum you might make 80 to 100 plus citations, so that's a lot of work. Yeah, this might be an overwhelming process, and it goes up for master's degree and PhDs. Yeah, so finding a good way of tackling this is essential to be efficient and effective. My name is Ipal, one that you're here. I'll be producing videos to help you tackle research projects. Yeah. So I've made a series of videos. Yeah. So this is an outline of the foundation of videos I'll be making. This video is about the science of research. So I'll talk about the principles and the principles of science in research in the first video. How to find a good research topic, introduction to the science of research. The second video will be about the actual finding of a good research topic. So I'll talk about how to find a good research topic, the rules and the rules of topic generation. Yeah, so I'll talk about the rules of topic generation in the second video. In the third video, I'll talk about how to effectively search and extract data from journal articles. Like I said, it can be a daunting task to extract data from journal articles. One article can have 10 to 20 pages just on average. Yeah, it can be more than that, it can be less. Yeah, so that's an average of 600 pages. That's if you are doing a degree. This may vary with university. So if you are being told to review maybe 40 to 50, yeah, that's about 600 to 700 pages of articles. So I'll talk about ways you can be more efficient, techniques you can use to be more efficient. Yeah. So the fourth video will be about how to develop a research topic, problematization and conceptualization, how to add flesh and meat to your topic. So problematization is all about finding weaknesses in literature, or not necessarily weaknesses, finding areas which are uncharted, where other researchers haven't tackled, or weaknesses in literature. So I'll talk about that. Yeah, you back up your claims with facts. Then conceptualization, how to develop a proper model for your research. So these videos will be mainly about social sciences, that's psychology, business, and sociology, whatever things which has to do with human behavior. But I also talk about natural sciences as well. Yeah, so I'll talk about that as well. And the first video is essential it can be useful for both social and natural sciences. The fifth video will be where I'll give an example of a good research topic, or examples. Yeah, I'll give some examples of good research topics, and I'll give one particular example where there's a valid research gap. I'll talk in depth about that one. Yeah. The second one will be the second last video will be about finding a good research topic using systematic literature review papers. So I'll talk about the types of articles in this video. Yeah, so I'll talk about how to use systematic literature review papers, which are robust reviews of original empirical articles. Yeah, so I'll talk about them, how to use them. Then the seventh video, I'll talk about the software tools for research academia. I'll talk about data types and research designs. Yeah. One thing I forgot to mention in the second video is that I also talk about the pitfalls, things to avoid when you're doing topic generation. Those things maybe you might not know about them at this stage when you're developing a topic, but you might learn about them while you're doing research design and everything. So I'll talk about those in the second video. That's it. Let me delve into the nitty-gritties of this video. So how to develop a good research topic. Introduction to research and the science of research. What is science? What are the principles of scientific thought and the rules of research? So science is a collection of objective knowledge that was derived through systematic investigation, that are well described such that they can be replicated. So science is a collection of objective knowledge through systematic investigations that can be replicated in different contexts. So yes, science is an ever-growing evolution of human knowledge about our surroundings and ourselves. According to Moore's law, information doubles every 12 to 18 months. That science is dynamic and subject to change. So science is ever evolving. According to Moore's law, information doubles every 12 to 18 months. So whatever things which have been done maybe in the last 20 years become obsolete. So like in research, you'll be using journal articles. They may range, this may differ with university, they may range from 5 to 10 years, the past 5 to 10 years to the current date. Yeah, so science is ever evolving. So all the information in the world, every after 12 to 18 months, it doubles. So that's according to Moore's law. Now this is a quote by Daniel Boorstin. The greatest obstacle in progress in science is the illusion of knowledge. So you never reach in science, there's no arriving. Every time, science is constantly evolving. So that's like backing up the claim of Moore's law. Yeah. So let me talk about the scientific principles of thought or thinking or rules of conduct in research. Yeah. Science needs to be built on the foundation of logical arguments, proof, not belief or authority. So science is built on objective, rational, logical knowledge. Yeah. Not beliefs, not authority. Truth is truth in science. There is no democracy. One can be right and the crowd can be wrong. Okay, that's self-explanatory. Scientific evidence, proof needs to be based or built through experimentation that is replicable and unambiguous. So whatever evidence in science, it has to be built through experimentation. And it has to be replicable in different contexts. So if you do an experiment in Zambia or in Africa, it has to be applied. You can do it in America, Asia, or whatever part of the world you are. Unambiguous, it has to be clear. Not basically easy to understand, but it has to be clear. Maybe by experts, but it has to be clear. No gray areas. A research report, so whatever research report you be building, it has to have a novel aspect, a new aspect. It has to bring out new knowledge. Yeah, so you can base your research on usually in research we base our knowledge on what people have done. Let's see if I've got, let's see, okay. Yeah, we have seen this is Google Scholar. That's why you'll be getting most of your articles. You can even use Google. I'll talk about this in depth in the video about extracting information on Google, extracting information from journal articles. So this is the motto of Google Scholar, or you can say standing on the shoulders of giants. So whatever thing you be doing, to be building on what has been done in the past, and whatever research you have, it has to have a novel aspect to it. Reporting of research must be done in an unbiased, concrete, coherent, and logical manner. So it has to be no bias. It has to be flow with data. Yeah, so it has to be logical flow. There has to be flow, meaning it's coherent. So I'll talk about these two in detail. In areas of research where there is soft knowledge. So what does soft knowledge mean? And uncertainty. Researchers are allowed to speculate and grounding in their reasonable or logical thinking until clear data is found. Science or knowledge found in science is never final. Science has neither final goal or objective, no final ultimate theories. So there's no final theory in science, or ultimate. So what does this mean? Soft knowledge. Let me give an example of the two most famous theories in the world, the Big Bang theory and the theory of the origin of life. For the Big Bang theory, a lot of theories about the origin of the universe. One of them is, the most famous one is the Big Bang. The other theory is like the theory of multiple universes and everything. So according to the Big Bang, the universe started 14 billion years ago, or 13.8 billion years ago. That's according to what's hypothesized by the Big Bang. But this raises a lot of questions. Why didn't it happen like 100 billion years ago, 1 trillion years ago, or 1 billion years ago? Why did it happen? Why did that happen at that time? We don't know that. So there are a lot of questions there. And before the Big Bang, at the Big Bang, time, space, and matter was created. Before the Big Bang, when did it happen if time wasn't around? Can nothing create something since matter wasn't around? And where did it happen if there was no space? Yeah, there are a lot of questions there. So yeah, it's just a theory. It's not concrete. There are many theories about how the universe started. So some people who refuse to follow the religious route or whatever route they speculate about, they use speculation using science on how the universe started. Then there's the theory of the origin of life. Charles Darwin talked about the theory of evolution. Now, modern science kind of brings a lot of questions to that. Since the discovery of the DNA helix has got, it's kind of like a computer program. They even call it the genetic code. It's got kind of like software. It has got instructions, precise instructions. Tells what part of the body or cell body, if you go to the simplest types of cells, tells them what to do, if you have to digest that, all those things. So there's a level of organization which is really crazy. It's a bit like going to the moon, then you find a laptop, then you're like, the laptop was created. But scientists hypothesize, it's possible for organic matter to naturally occur in the universe. But how did life happen? Like, life is not just a bunch of organic molecules, and the type of organic molecules which make up life are really complex. So, and there's a genetic code. It's a set of instructions. It tells what's usually found in stem cells, like those are embryonic cells. Yeah, so let me not delve very much deep into that, but yeah, no one has proved in the scientific community about how life originally started. Some speculate that it came from another planet. They call that direct panspermia. Yeah, but that doesn't answer how it started. Yeah, so there's a level of detail in cells. Scientists can't even create cells, living organisms in a lab. So that's how difficult it is. So that's some gray area part of science. Yeah. So that's it about. So that's what it means by soft knowledge, uncertainty. Those are areas where scientists can't explain things. Yeah. Science is ever changing. So whatever, this may sound taboo, but when the most fundamental laws of physics, like the laws of thermodynamics, energy can be created or destroyed. Maybe after 400 years, those laws might be scrapped off, though that sounds a bit taboo in the scientific community. Yeah, so that's it about soft knowledge and uncertainty. So there's science or knowledge found in science is never final. Science has neither final goal or objective, no final or ultimate theory, so it's subject to change. So that's the highest truth. The highest truth in science is that there is an illusion of knowledge. Yeah. So the greatest obstacle to progress in science is the illusion of knowledge. Yeah. That said, let me talk about the types of you may categorize science in different categories. So I'll just mainly talk about natural sciences and social sciences. Natural sciences investigate and may analyze physical aspects of our world or the known universe, while social sciences examine, measure and analyze social human behavior or among human beings and their environment. So our examples of natural sciences are physics, chemistry, biology. Math is sort of a language, it can be used in anywhere. Yeah. So math, physics, chemistry and biology, those are physical sciences. Then they stem off to things like engineering, biology and everything. So math is like kind of the universal language which is used in either social or natural sciences. Yeah, so they measure the physical or tangible aspects, mostly the physical and tangible aspects of the known universe. Then social sciences, these are specialized to measure, analyze, or even predict human behavior among human beings and their environment. Yeah, so examples of social sciences are the study of psychology, sociology, political sciences, even business. Yeah, there are a lot of examples you can think of. Yeah, basically measure human behavior. So how do reports differ? Dissertations, a thesis for social science and a natural science, how do they differ? Well, social science is usually grounded with some theories. Yeah, under the conceptual framework, I'll talk about that. Then natural sciences, they are grounded in laws like the law of gravity, the laws of thermodynamics. Energy can be created or destroyed. It's just transmuted or changed into one form or another. Yeah, so that's where the things differ, but they do both do carry out experimentation. Yeah, so one touches the physical part, one mostly the intangible part, which is human behavior, trying to predict human behavior. Yeah, so with that said, let me talk about research. So this video is useful for both people doing natural sciences. Yeah, so if you learn about research, even if you're doing social sciences and you want to get a degree in a field with natural sciences, it's very easy to switch. Basically the principles are the same, it's just that you will be using a conceptual model, then they'll be using laws, conceptual framework which will be governed by some theories of human behavior. Then the other people will be governed by laws of the universe or science. Yeah. Research. What is research? Research is a systematic and scientific, robust way of carrying out investigations that are so well described, clear, coherent, concrete, logically structured, such that it can be repeated anywhere, in different contexts. In the process, accumulate new objective knowledge. Yeah, so whatever research you're doing has to accumulate, it has to have a novel aspect. Accumulate new objective knowledge. Like I said earlier, being objective means being rational, logical, not being subjective or to bias or any other things or authority or beliefs. Yeah, you just look at the facts, you experiment. You don't know where the research is going, you just go with the flow. Yeah, you just go with what the data gives you. Yeah, that's what I can say. Yeah, so I'll talk about the principles of research. What do I want to talk about? Okay, I think I've forgotten what I wanted to talk about. Okay, let me just continue. Principles of research. The first principle will be ethical consideration. This is adhering to ethical guidelines, ensuring the well-being and the rights of participants. So you have to have some ethical consideration in your any research. Like one of the rules I'll give when doing topic generation, your title for the project doesn't have to have the name of an institution, maybe even a person, I guess. Okay, not a person, but an institution, yeah, without their permission. So you don't do that. So that's like part of ethical consideration. Okay, let me skim through. Transparency. Clearly document research methods, data collection and analysis, processes for reproducibility, objective knowledge, maintain impartiality. Yeah, so you have to be impartial, you don't have to be subjective, biased, minimize bias, research design, data interpretation and reporting. Validity and reliability. Ensure the data, the study measures what it intends to measure and produces consistent results. Like I'll talk about internal validity and external validity in research. Internal validity is the extent to which the study measures what it intends to measure. How accurate is your study? Basically, it means accuracy of the study. Then external validity, the extent to which the findings of the studies can be generalized to different contexts, maybe a different part of the world in different contexts, and how representative is the sample of the study. So if you shouldn't use unbiased samples, like the sample is a small part of the population, you want a sample which represents everyone in the population. So yeah, I'll talk about that. Peer review, you Research has to be subject to scrutiny by experts. Hypothesis testing, clearly state the hypothesis and use of rigorous methods to test them. Contributing to the scientific process. Sampling techniques. Employ representative and unbiased sampling methods. Generalizing findings to broader populations. So that's like part of external validity. Data quality. Collect and analyze, interpret data accurately, address potential sources of error or confounding variables. Yeah, so I'll talk about that later on in detail. Informed consent. So this is part of like ethical consideration. So it's still part of it. Obtain voluntary informed consent from participants representing their autonomy and their rights to withdraw. Publication ethics, still part of ethics in research. Adhere to ethical standards when disseminating research. Findings, avoid plagiarism. Ensure proper credit, so you have to reference your work. So all this is done to promote integrity and reliability in the research process. Yeah, so you have to follow these principles so that the research process is credible and reliable. So with that said, so why do you write a research paper? What's the essence? What's the point of writing a paper? The purpose of a research paper, report, dissertation, thesis, is to communicate new information and knowledge. It reports the new findings of a research conducted and adds to the existing body of knowledge. The report acts as a user guide or a manual for scholars. Thus, the research could be replicated, adapted, developed to be conducted in different contexts. The research can be used to aid decision making. Research can be conducted by both private and public sectors to aid the decision-making process. So that's about the reason of coming up with a report here. So this is basically an introduction to topic generation. I'll go in depth in the follow-up video. Yeah. So let me talk about problematization and research gaps. Research gaps are weaknesses in prior studies or uncharted areas of research. Those are areas where no research has delved into, or they are not few people have delved into. So problematization is a process of finding weaknesses in prior studies, backing up some claims with facts. So when you're problematizing, you find weaknesses in prior studies, you find motivational factors, so you can pick whatever topic you want to pick, whether it's something you like, as long as it's in the boundaries of your field of study. So if it's in the boundaries of say medicine, you can pick any topic. It can be public health, clinical, whatever, biochemical, whatever. If it's business, you pick something. You can pick anything as long as it has got a business aspect to it. Yeah, so you can pick that. So you have to ask yourself these questions. What are the weaknesses in prior studies? What problem or need is the research catering for? What does the literature say? So you have to when you have a topic, I'll talk about that in depth in the next video. You ask yourself, what does the literature say about that issue? Is it studied, or there's few literature about that? The body of facts and statistics. How can this problem be addressed? How does this aid the body of research? How does your research aid the body of knowledge? How can this be used by scholars, practitioners, and policymakers? So What's the use of your research? What application? How useful is your research? So all those questions you have to ask yourself when coming up with a topic. So let me talk about types of journal articles. This is I sourced this from Cambridge University Press, but names may vary. Yeah, I'll talk about the main journal articles, which are the research article or empirical article, then the review article. Then I'll skim through these. Yeah, those are the main articles which people use. So a research article, it's the most common type of journal article. It contains original research contributing directly to the field. It applies to all disciplines and subject areas. Written by experts for experts. Must adhere to high standards of peer review, scrutiny, and scholarly communication. Then the other article which will be using those two articles. The first two, the review article, provides a comprehensive summary, discussion of a scientific research area, offers a new perspective or conclusion. Vital, so on this part, offers a new perspective and conclusion. So from there are types of review articles called systematic literature review articles. From those articles you can get the research gap. So I'll talk about those in depth. They offer a new perspective and conclusion. Vital companion to research articles, widely cited and attracts many downloads, contributes to the evolution of research. Then there are other types. I'll leave a link in the description so that you can download this. There is a rapid communication, brief report, case report. So I'll leave a link for this document in the description so you can download the document. So that's about articles. So why is it important to know about these articles? So the main articles which I used for the literature review table will be empirical or review articles. Empirical or original research articles, or original journal articles. Then you can also use literature review articles, like systematic literature review papers. Those are very important articles. They give an insight to the current, the past, and the future directions of research. So with that said, thank you for watching this video. Please subscribe to my channel and call it a day.